Hi, Paul. Welcome back.
Hi, great to be back.
The most important question is, what's your favorite coffee?
Oh, that's a very good question. I'm actually drinking a coffee right now, and I can't remember what it is, but my better half orders it in a big bag, and we have
Okay.
a coffee machine with the
hmm
beans, and it's very pleasant coffee. I think
Okay.
it's the way to go, rather than
Okay.
spending $5 at Starbucks every time you want a coffee. Is bring the coffee machine to your home and buy the beans.
Okay. So, but you have the Italian machine, so where with grinder and or is an automatic one?
It's an automatic one, so
hmm
I think it's a Swiss make the advertisement for a Swiss coffee machine, Jura.
I had this one, and it didn't, and it was not very good.
Uh,
And I did a long investigation why, because I couldn't believe everything was better than the automatic coffee machines. And I found why, and it's a actually surprising result. The automatic machines are really hard to clean inside.
yeah.
And if some coffee is left over, it is really sour. And if you have these simple machines, the Italian one, they are very easy to clean
Mm.
because and this was the best explanation ever because I think this is crazy that I know that there's a difference in taste between a
Yeah,
simple coffee machine and the
right.
automatic one and
Yeah,
I couldn't believe it's like this is like this is like a placebo effect, but there should be a reason behind it, and I found that this was interesting.
interesting. Yeah,
Yeah,
yeah. That's we had those big. I think you're talking about those big sort of. You can get small ones, but these big industrial coffee machines where you got to sort of.
yeah, exactly. The
We
basket,
had
right?
those in some microsystems when Sun was doing really well.
Mhm.
And they brought those in, and so we could all make our own coffees like this. And my first thought was, if I ever lose a job at Sun, I will know how to be a barista because I can
Yeah,
make coffee from these things.
but this one is the expensive option, but there's a very cheap one which also tastes great. A
Mhm.
little bit more work is called Aeropress. You are aware of it?
I've heard of those. Yes, yeah,
This is like $20, I think.
yeah. They're
Uh,
look very effective, almost like portable. You could take them with you.
yeah, yeah, they're even ultra portable, a smaller one, and the regular one is like this. And it is also easy. There's nothing to clean basically, but this is like a tube, a plastic tube, but it works perfect.
Yeah,
But we wanted to talk about Java a bit, and I saw
Mhm.
you are busy. You wrote an article,
I did.
right?
Yes.
How long did it took to write such an article?
Um, I perhaps we should explain what the article is for.
Automatic differentiation of Java code using code reflection.
Yeah, so this is the first article of a couple around the Babylon project
hmm
to try and explain at a high level
hmm
how you could use this feature. There's a real challenge here. One is you could explain it at the sort of bottom level and be really abstract,
hmm
or you could explain it at a high level with a particular use case, and then you got a challenge of explaining the actual use case plus how you use it at the same time. So I'm trying to go from the top down with these, and we make other articles as we go, and we'll see what the feedback is. So this is the first one. This took a couple of weeks to
hmm
write over a period of actually a year,
hmm
on and off, just tinkering at it. First of all, to write the test code itself, which has been around for a while, and
hmm
then to write the article, especially the introduction on the
hmm
machine learning side.
hmm
It takes quite a while with some feedback to finesse it, and it's probably still errors in there in some form or another. In fact,
hmm
someone already found some typos and submitted a patch. But it's of reasonable quality. It's more like a blog or an article rather than Brian Guts writes these very erudite design documents, say on patterns and stuff like that. This is not this type of document yet. This is more of a blog article in a sense in terms of quality, I would
hmm
say. But we still try and take time to get it
I
right.
didn't read it fully because I found it before the show.
Mm.
But I took a look at the code. It was already helpful with the annotation. So now to get okay, something is transformed here. Just to Esma to get the idea how it looks like. There's lots of source code. But I'm glad that you said a couple of weeks because if you would answer 2 days, then I have a problem. Because I thought this is huge amount of work. But this is nicely written and
Yes,
okay.
exactly. I hope it inspires people, first of all, to see what you can do and to understand the use case, and maybe take a see this. This is a very, very small prototype proof of concept,
Hmm.
and maybe it inspires someone to do a proper job and to write something really
Hmm.
can
Hmm.
differentiate a broad set of Java methods in maybe using reverse mode auto differentiation, which is a lot harder to sort of comprehend, I think, than
Hmm.
the forward mode.
Half an hour ago, there was an online streaming live stream called EHEX TV, and I got one question in the chat about WASM.
Mm-hmm.
How to do it with Java? How to how this would be if we have a WASM in JavaScript, like it is like isolate encapsulated
Yeah.
module. Is it possible to do it with Java? And the translation would be as Babylon, but with Java modules, we could have nicer dependency isolation, and with GraalVM isolate, we will have to isolate. So it would be actually, then we would get a nice Java cloud service, Java as a service in the
Yeah.
cloud, and but this was one of the audience, so they asked the questions. Okay, funny because I talked to you now after the show 20 minutes later, and the question was not about transformations rather than how to run it, but it is people are actually thinking about this more and more.
Yeah.
And the Tornado VM podcast, what they also try to do, they would like to commercially, have enterprise integration with Tornado VM,
Yeah.
exactly what we talked about last time. So it
Yeah.
seems like this is the right path to go.
Yeah, I think in the WASM case, it probably depends on what you want to do. I mean, I think it's very challenging, at least as I understand with WASM. I'm not an expert on it, to support a fully managed runtime on WASM yet, although they may be trying to enable that. I think GC is particularly problematic. So it's not currently designed for that. It's designed for these like smaller isolated functions, as you say. And if we're thinking in that mode, you're in a more constrained programming model.
Yeah.
And then you can think about it as rather than a Java runtime, a transformation to an alternate runtime where you preserve some of the program meaning, but you don't preserve all of the Java semantics. So I think it fits there in that context.
So I give you a very, very concrete case. So, for instance, in a current project, we have a challenge with SSL. So we have to pick a very specific cipher suites, which is not possible from configuration perspective. So what we will need to do is to write some kind of function, maybe, which looks at the header and decides is it allowed or not allowed. And for instance, I already know there are JavaScript functions available, serverless functions, and WASM as well. So this will be a perfect case because we could write unit test code in Java, which gets the header and decides yes or no. And then I cross compile this function, which is very simple, to WASM, and I'm set. So what I already noticed, you all are perfectionists, right? So at the at the Java team, and I think most of us would be happy with 70% solution if it is described that well. I think no one has the expectation that it will cross compile Glassfish to WASM. I think this is crazy. But let's start with a function, and if it works, it could be static one, right? So static Java method in an interface. It's good enough as beginning, right? So and
yeah, those types of simpler use cases or more constrained use cases definitely could be amenable, and it's kind of use case we're thinking for the GPU as well. Although there's maybe broader programs, but it's sort of like constrained, bounded within certain. It's not sprawling over your whole program, and in fact, Gary Frost has been doing this. He's been lifting up using code reflection to generate OpenCL C99 code as an example, which can then be compiled using OpenCL compilers. As for GPU, that's just one experiment, but you can sort of do that. And he's been diligent in making the code actually human readable. So there's gone the extra step, but you don't have to if you don't want to in that sense, if it's just consumed by non-humans. But it's also easier to debug if it's readable. So there's various angles you can take here, as long as you don't need a GC, as long as you can reinterpret what math.sign is and stuff like this. You can be quite flexible in target.
In most enterprise project, it is serverless, and serverless you don't need GC per definition because it is called and it dies afterwards. So it is like there's nothing to collect, and the cases are mostly simplistic. So like should we cache or not cache? Check the header, transform the header. This is actually if else basically. But with Java, we know Java. There's the entire CI/CD pipeline, and unit tests everything is working. In Wasm we have nothing, so it just to switch to a different language to a Wasm is not a good idea in enterprise. I would say.
I don't know a lot. You shared me some links last time on the Wasm stuff. It was quite interesting, and I was wondering, wouldn't it be easier if they could accept bytecode as well?
Paul, absolutely. So actually, if you look at Wasm, we could become angry because it's actually what bytecode we had 20 years ago. But what I notice sometimes, the JavaScript and Python developers don't even mention Java because they don't like it. And if new companies are just accepting Wasm, I think it's also because of marketing, right? So I mean, there is something new, and they can sell new services. If they will say we are Java shop, I think there's nothing new. But if you sell a Wasm cloud, then we are talking. But nonetheless, the companies are out there, and we could, if we have already Java, we can support the Wasm. But you are absolutely right. I don't understand it either, because with a class loader and a module, we would have the best possible runtime. But still, the community just would also like to have Wasm as well. So okay, then you have your Wasm.
You can. There was that blog entry you sent on Aurelia. It's an interop mechanism. It's another form of interop mechanism with some interesting ways to constrain put some constraints on the program, i.e. what it can consume, what it can produce, what its resources can be, and stuff like that, which is not something, say, Java or C# as a managed runtime might have in that sense. So they're thinking slightly differently. That produces some interesting interop boundaries, I think, where it may crop up.
So what we wanted to talk a little bit more is Panama, right? So this was
you can talk anything. Ask me anything if you want.
Yeah, but Panama, you are also active in Panama. And as a side note, what I also found per accident, did you know that there is a project where with plain Java load the Llama model?
No.
I will put you to the show notes. So there is with the Vector API. This is GraalVM team member loads with Java 21 with a single class the Llama model with Vector API and executes the entire thing.
Oh yes. I know now. Yes, that's right. Yes.
Okay.
All now. Yeah.
So I will add it to the show notes. It's basically Java 21 class with uses the Vector API to integrate between Java and the Llama long language model from Facebook.
Yes.
Yeah. You are aware of the code?
I am briefly aware of it now. I just sort of like recalling it in the back of my mind, seeing the code.
Do you know what happens behind the scenes there?
When you execute Java code?
I mean, runtime wise, because we have a Java with the Vector API and we have Llama from Facebook.
So the Llama, the sort of, as I understand it, the LLM is just at some level is just some bits. Of course, any code is just bits.
Yeah.
So the model is effectively some form of instruction, but it's a mathematical representation of some bit of mathematical model with constants in it that's being trained. And then you have to run over that mathematical model, which is effectively forms of matrix or vector multiply on that, so that your interpretation is implementing the running of that model as a mathematical function. And it just so happens that the operations of matrix or vector multiply are very amenable to CPU hardware vectorization. So rather than doing sort of scalar operations on it and hoping the compiler may be able to auto-vectorize it, you can do that explicit vectorization yourself using the Vector API. And what will happen is when the C2 compiler in Hotspot gets at it, which means it's all warmed up and profiles, it will turn those those calls to the vector class into hardware vector instructions. Just like a int B, and add them together, it replaces whatever the interpreter does eventually with a hardware instruction to add two 64-bit numbers together. But you can do the same to add two vectors of 8 64-bit numbers together if you've got enough information in the compiler at runtime to drive that compilation.
Okay, this is what, from the optimization perspective, but my question is even simpler. What I understand, so the Llama ships with whatever, it is something, right? This is a format, and Java is able to read the format somehow.
Yes, it just parses it in. It's just a series of floating point numbers and perhaps some structure or header information surrounding it, giving the details on its size. I'm not exactly sure, I'm guessing, but there's probably some metadata describing what it is, and then there's a big, humongous set of matrices describing the model.
Mm-hmm. Because I always wondered, I know there should be a standard format for the models. So that
there is. There's something called Onyx.
Onyx, exactly.
Yes.
So, so what it means is, this was the next question. So the Onyx, so the Llama model, let's say it is in the Onyx format. So and Java just parse the Onyx format, and this is the entire trick, right?
Yeah, it could do that, or it could run it in Onyx itself as natively. There's lots of options here. Adam Pocock from Oracle Labs has written actually using JNI, not Panama yet, a binding to Onyx where you can do this. If you're in Onyx, you can run the model directly in Onyx, or you could implement the model in Java and parse the data in. There's various options you can do in that case. In actual fact, related to Onyx, what I'm interested in is can you write models in Java that can be reinterpreted as Onyx models using code reflection. So we can, rather than, often people write these models explicitly like building up an AST of the Onyx model using a very low level API, and no one wants to write that. They want to write real code. So rather than writing an AST node for a for loop, you want to write your for loop in your language. And so if you can express what you want in the pure language that you have and then translate that to generate the AST of the Onyx model, then I'd be interested in that from a code reflection point of view. And then you've got options. You can load the Onyx model and run the Onyx model directly, or you can write your own interpreter for that if you want. But I would say there's been a lot of optimizations around Onyx execution natively. And so if you've got that infrastructure and the GPUs and stuff like that, you're going to be hard to beat it, I would say.
Okay. Because this is what I wanted to ask you the last time, but it's really hard to know to frame that question. So, because for me, there are two parts. It's like, the model is like the state, what was trained, so which has to be loaded. Yeah. And there's the execution model, which gets the model in and does something with it.
Yeah, I see what you're getting at now.
Yeah. And so, okay, if this is written in Python and the model comes as a number and the interpretation runs in Python, forget it. Yeah, no, this is, yeah.
If we use PyTorch or what, I can't remember the various libraries. PyTorch is a
but still, the libraries, if they are PyTorches in Python, then forget it. But if they are natively implemented, there's maybe C or C++.
Yes.
So they are very fast.
PyTorch is a wrapper around various native libraries, which will execute, and very optimized native libraries as well, which are highly optimized.
But if you forget now Python and just focus on the native libraries, so there is almost the GraalVM story, because let's say if the native library is comparable to JVM, it could be implemented in Java, right? Pure Java. So this is what we're also talking about. So it would be interesting to look at the Onyx level and say, okay, if you do it in Java and then we load, the numbers. So if it's not faster, at least we have a tight integration. Without any JNI, we can run pure Java, the entire process.
Yeah, you can certainly implement it in pure Java like that. The challenge is to optimize it down to very efficient machine code. And sometimes that's quite a challenge with matrix multiply, because it's not just the arrangement of the those three loops that you have, it's also the data movement as well, and it's often optimized based on cache size. So it's amazing how academics can make a career just out of matrix multiply. There is literally people can be whole academic subjects on this and architectures and so forth. And you see it playing out in the industry right now as people are pushing GPUs and they're not fast enough and they're doing their own TPUs, stuff like this for it. And so it's hard to beat, and you need specialized compilers to do it. So that's where you see MLIR coming into play that helps drive the sort of generation of these very optimized kernels with data movement in them. But it's extremely hard to beat a very good native library. So my recommendation is to try and push the Java side as much as possible, but in the interim, use Panama and use a native library and build on top of that. And you can build some quite nice sort of systems based on top of that.
So what you're saying is that on the native level, for the execution, all the vendors are working, together to have the highly optimized solution, and it's hard to beat them because they're already working on the hardware level, right? So this is the expertise is there, and so the Onyx is the model, and you said executing on Onyx. So what it means is this is the execution on Onyx is exactly what you're talking about. So there is a low level C or native implementation of very efficient execution of the Onyx, which runs on optimized hardware, right? So this is
so that's the intent. Yes, so it may be hard to beat in some cases, but it doesn't mean we shouldn't research trying to beat it and seeing how far we can push it. But I think the most practical thing to do is to bind natively to systems in the interim of something better coming along. And Panama gives you that. And it allows you to sort of interop. You can choose to bind some bits and do other bits in Java if you want. So it gives you a choice. And so, the Onyx model comes with the sort of code to operate on the data. And when you're seeing the Llama model, we're just operating on the data and have written that transformer architecture in Java itself, where you can represent that transformer architecture as sort of AST nodes in Onyx, if you want. So you can think of Onyx as a sort of coming with some sort of abstract or intermediate representation of code. And then something will interpret it or compile it down to efficient machine code. It's often a mid to high level sort of compilation. It's not low. It tends to be not low level stuff. It's stuff that understands, there's a matrix. I'm multiplying two matrices together.
But it could be Babylon, all right?
You could, yes. Which is why I'd like to explore the notion of writing a model in Java and doing a graph extraction and translating that to the Onyx AST, which is what Swift for TensorFlow tried to do as a project. Unfortunately, it failed for a number of reasons, but it was an interesting experiment, and I think it pushed things further than other things did at the time. So I think some Python libraries may attempt to do this as well. They will scrape the Python AST tree and try and interpret or try and extract out the intent of code and translate it to, which is kind of like the code reflection feature, but for Java.
But it's a similar. I had that. I think it was 15 years ago at Java 1. James Gosling mentioned Project Maxwell, and no one remembers the name. Maxwell. And what Maxwell was, it was renamed several times, but the initial attempt was to rewrite JVM in Java, because they say, okay, the C is hard to maintain.
That was the Maxine project.
And then was Maxwell, then was Maxine, and then GraalVM happened.
Yes.
But I think they should have similar problems, because if they use C and C++ low level thing, so in one point of time say, okay, we could use a high level language and to make it more maintainable. And if we do it in Java and we have the full stack Java, there is no Panama. But I understand you. Is this okay? But in between, it is, we cannot just rewrite it because there's too much optimization when there, so we can just call it.
Yeah. As it's a noble goal. I think what Graal did, which is very interesting, is that we might be getting the name wrong here, but the meta circularity aspect.
Yeah, exactly.
It's quite clever. There's some Japanese academic Fukuyama machine or something like this. I can't remember the name of it, where it describes the levels of meta in compilers, and Graal's a great proof point of that.
Yeah. So now Panama. so the Panama is make JNI nice, right? Java native interface. This Java native interface is an old Java API or Java way to access C and C++ code actually.
Predominantly C. You can wrap the C around as long as you do the extern C for your C++ entry points. It's really a C. The ABI would be C, whereas C++ does not have an ABI in this in that sense.
And I tried to use it several times, but already passing string back and forth can be challenging. And if you have your own data structure, it is really challenging. So this is not a fun experience, and you have also problems with concurrency and garbage collection. And we have like JNI 2.0, and this could be Panama's to parse the memory access and foreign functions, right? This is what Panama, exactly. But you are the expert. I just tried to introduce,
No, that's a pretty good summary. I think everyone who's sort of dabbled in JNI has come away with some scars. You can do it well, but it's an awful lot of work, and it's easy to make elementary mistakes where you bring down the whole VM and hard to debug. I think in part because it tries to interoperate between the VM and the native, so you're passing references to Java objects through, which can make it complicated to do this translation to your native calls. Whereas Panama, first and foremost, its feature does away with that. You can't pass Java objects across the boundaries, so you're limited to passing in sort of primitive or compositions of or structures of data which have been well defined in terms of layouts. So it's a lot simpler model to comprehend, and it's also a lot of it's like Java on Java in a sense, but a lot of it's written in Java itself and leveraging the underlying invocation machinery that's highly optimal for invoking Java methods, and now you can invoke native methods using similar machinery.
And how is different? Oh, JNI was just memory access, right? Or what was the difference?
JNI is really it's how do you unpack it in a sentence? Well, first of all, you have to have your native C compiler to compile and a header file, and you sort of compile that in a way that generates these stubs for you that you then implement in C. But you have to pass the and then you define the interface in Java with native methods that correspond to the sort of translation to those stub methods you need to implement in C, and then you fill in the gaps there in C. And it's extraordinarily complicated. The developer has to sort of write in C, and they have to do that translation of the Java objects in C and make sure they get that right and manage the memory and everything. In Panama, you can sort of build up the description of your native method using this layout description language, layout artifacts, and then bind it at runtime to some shared object, some symbol in some shared object library, and then call it. And that's quite low level, but what you really need is a tool to look at the header file and generate the things you would write by hand yourself, so you get this sort of nicely, a bit like what maybe like JNR or JNA could do, I believe. I'm not too familiar with those technologies. So you get a high-level generation scraping the header file from which then you can wrap around a more idiomatic Java API, because what you get back is an idiomatic C API because it's naturally derived from C. But it gives you this huge productivity boost because you can focus on the creative bits rather than the manual bits. And a JNI is just, you're asking the developer to put one leg in Java, one leg in C, and do all the mechanical and the creative bits. And it's hard.
But my question was rather from the technical perspective. Yeah. So behind the scenes on JVM level, is this something is similar or is completely different?
It's actually different.
Okay.
Underneath the covers, there are some common similarities in the notion that when you make a native call, the JVM has to sort of transition and tell the managed VM, hey, I'm in a native call for this thread. And then when it exits, it has to sort of repatch things, go, I'm now no longer in a native call. So there's similarities between JNI and Panama native calls with respect to stuff like that. But with regards to the sort of the way it's the ergonomics of it and the design is very different in that respect. And so Panama currently can't do everything that JNI does for various reasons like that. You can't pass Java objects across the boundary, which actually is a limitation in some respects. So they are actually looking to see what mechanisms may support certain use cases to enable that to happen. But for many native stuff, you don't need that. If you're calling out to linear algebra library or something like that, you don't need that at all. So there's some commonalities because you make native transitions, but the approach is very different.
I had a chat with the Tornado VM, and they are migrating to Panama foreign memory. This is and they're really happy with it.
Yeah, it's working out well for them.
I had a chat with Mr. Bechberger, that is going to be also published on this podcast, about eBPF Java binding.
On what he did. That would be a crazy one to try and do using.
Yeah, what he did, we used JExtract to generate, from Linux C all the Java wrapper, and is able now to write eBPF logic in Java and push it to the Linux kernel.
So what's he writing the eBPF logic in? Is it just strings that he's passing?
Currently, it's just strings, but he's able to deploy everything in Java. And I immediately thought about Babylon, right? Because this would be also a very, very good use case, actually, to have a Panama with Babylon, and we could write eBPF completely in Java.
That's what I was wondering. I thought about that a while ago, thinking it might be a crazy thing, but it actually doesn't sound so crazy when you put it like that. I always thought a couple of years ago that code reflection plus Panama would be quite a powerful feature. And we're seeing this play out with the GPU work we're thinking about. And you can see it playing out with Tornado VM on the Panama side already. The two combined work well together. We want to use a lot of native code where we can because it's already there and it runs really well. But we want to use it from Java and make it really Java and friendly and productive to use. And so the two combined can be really powerful. I hope to see that play out more to prove the point.
Let's say we have Rust could also work, right? There's no problem. We have a Rust function with two integers in, one integer out. How the process looks like with Panama to access the function in Rust? Or C++ or whatever, but Rust is...
I think if that, say you're compiling that function to Rust and making it a shared library, shared object library, and you mark that function as, say, like extern C. And
so the extend C is the important part, right? So
So if it could conform to the C ABI, and then you could look up the symbol in the shared object library, then you can just use Panama today for it. Now, if Rust has its own ABI, potentially in the future, we could write our own linker that understands the Rust ABI. So we're not entirely tied to the C ABI, but it's just the most common one, available one out there. In fact, the only sane one out there that everyone uses natively. But if Rust got sufficient traction that it had its own ABI and you could interact with its own ABI, we could define a linker to understand what that is. And so the Panama linker is a thing that translates the sort of Java method call invocation to the sort of native ABI, messing around with the stack, what goes on the heap does a native call and translates the results back.
What I did, I don't know, last year, just try it out. GraalVM supports LLVM bitcode, and you can also call stuff via this.
Yes.
And this was interesting for me because it's just almost like this was like alternative to JNI back then. So this is like I can just call something from GraalVM.
If you have the LLVM bitcode available to slurp in, if you like, so Graal can see it all, then yes, you can. It's sort of almost like an embrace and extend model, isn't it? In a sense, rather than saying there's a shared object library in there. I'm going to slurp in all my code. I can see it all and optimize it all.
Yeah, but the crazy part is now for Java developer, it's not obvious how many options we already have. So we have the JNI, we have the Graal VM route, and there were, I think, two ways to access the Rust LLVM and JNI, and they have even a proprietary way. And now we get Panama, which is of course the standard, which is also nice. So we have already a couple of them. Of course, Panama is the way to go because it becomes with the JExtract tool, and it's the most, I would say, how to call it, standard, right? So this is an OpenJDK project is going to be part of Java. This is the standard way to go. So so you have to say, you said extend C. This is important. So whatever we have in different languages, if there's an extend C API, we're already good, and we will look up the thing in the symbol table. And then Panama is happy, right? So
yes, effectively, you've got a sort of shared contract. When you look it up in Java with Panama, that symbol, you're saying, oh, I know what I know this is pointing to a function, and I know what the function signature is. And so you derive it from the header file. And so if they deviate, of course, you're going to have an interesting time, but you assume they don't deviate.
Yeah. Segmentation fault?
Or whatever, yeah, even corrupt code. Anything.
Yeah, I just remember segmentation fault from a C++. So my most common error, segmentation fault, was if I try now. Yeah.
Yes, I mean it's worse when you think about it from a managed VM perspective, because you may not just be corrupting user data, you may be corrupting VM data. And when you corrupt VM data, that can even be more problematic, because you get the errors can either be at a distance or just corrupt you in ways that you can't determine what's going on. And that's the danger when people use unsafe as well, as they may think they're operating on their own data, but they may incorrectly be operating on VM data structures as well, or internals in the VM they think are safe to operate on, but actually are not because they changed. And the impact can be quite profound, and not necessary to them, because the library could be 10 libraries deep in someone's application. And I think that's problematic. And at least with Panama, when you go native, you can't avoid that potential, because obviously in C you can access any memory that's not constrained. But in Panama you have to opt in, and you have to say, this, I'm going native, and the application has to opt in and be cognizant of that fact. So at least you have a signal that, or a choice not to use it. If the developer goes, no, I don't want native, so I'm not going to opt in.
Also important from security perspective, right? Because you could, exactly. So, okay, so I have the extend C function, and how JExtract helps me. So what?
So an example, what I have, I used JExtract in Panama to bind to a native linear algebra library called Bliss. Which is quite highly optimized library for matrix multiplies and other things. And I could hand code all the bindings myself and build up low-level things. We build up these things called method handles, which native method handles, and bind to it and write all the layouts of all the structures myself. And
how you would do this yourself? So how you would practically do it? You will look at the C code and know, okay, this data structure in C is.
You look at the C header, and you write the equivalent layout descriptions in Java code. Oh, that this is a structure. Okay, layout structure. Oh, it's got an int, and then I've got to work out. Oh, it's a CABI, and it's on x86. So there might be padding between these two struct values. You really got to understand the layout, because if you're defining a struct in C, what actually gets represented in memory is not necessarily directly what you're saying it in. It might be if there's like a sequence of ints, but if there's an int, a byte, an int, there might be padding between them, and stuff like this.
This is a really low level.
Yeah, you've got to be quite careful in that way. You can do it, and for simple cases, it's pretty easy to do. But as the structures get more complex, you're going to make mistakes. So you need a tool to understand what architecture you're targeting and the header file you're targeting. And if JExtract is that tool, which will effectively uses Clang as a header file, use Clang to get the AST tree of the header file, and then it just traverses it's not just, it's non-trivial. It traverses the AST tree and then generates all of the Java code that you would need to bind to the native functions in that tree, not just the functions, but to the memory as well, the structures. and interoperate with those two. And it generates all that for you. And so I used that for the linear algebra library, and it was a really good developer boost just to get up and started, which I then wrapped around a nice Java layer to make it easier for Java developers and less C-like. But the interesting thing was you could code using the lower layer that JExtract generated, and it looked almost like the code you'd write in C. It was you could compare the two together, and it was very similar.
Yeah, this was actually my question: how nice or not nice the JExtract code is, and so I'm this the as I just opened that. This is the okay. I'm now in the foreign memory segment and value layout, and what is actually generated by JExtract. I see. Okay, this is compare FNT Java. Okay, this is ugly, but it has to be ugly because it is defined that way. I mean, it is not ugly. The problem is, the C looks different.
Yes.
There are different coding conventions and naming convention, which look ugly in Java, but if you are accustomed to C, it is beautiful, right? So this is the problem.
Exactly. You don't want Java developers coding to that you don't want to. What you don't want to do is, which would be unsatisfying to me, is point JExtract as a common C library, and then expose that out to developers as the Java API, end user Java API, because that is inevitably going to look C-like. It's just naturally so, because that the creative part, the tool can't do the creative part of the process. It can make it easier, and there's various things that can be done to expose structures out a lot more clearly, perhaps, or high-level concepts of pointers and so forth like that. But at the end of the day, you're going to be calling C, and the C API may pass you void pointers back that you have to free explicitly yourself and so forth like this. There's very common patterns of how it controls memory. You have to wrap that around it. If you're going to expose it out to Java developers as an API rather than just use it internally for your own purposes, you have to wrap it around something that's idiomatic to Java developers. And two examples. One is the linear algebra library I did. I wrapped it around a nice Java matrix API. Another example is University of Dusseldorf. They were investigating Panama with RDMA networks, and they bound to a library called UCX, which allows you to do RDMA communication, and that's useful for very low latency, high bandwidth networks. And they wrapped it around the idiomatic API called InfiniLeap, which made it easier for Java developers to use. So all the creative process went around in that sort of how do you expose it out to Java developers.
So I just look at the JExtract GitHub page, and there was an example with the point to get a feeling how it looks like. And I think the big deal is the layout, right? So you could do this layout, but I think in no enterprise project, as in my world, is a no-go. I mean, this is not maintainable. Even if you could write this, how to test it, how to forget it, I would say. Yeah. So the JExtract is a very important tool to do that. Now, so back then, I remember the costs of calling C were very high. So it was not always worth to use JNI because the overhead was high. Is the overhead lower in Panama?
Yes, and similar depending on what you're doing. So there's always going to be a cost to do a transition from a Java thread to a native thread and to patch up the registers in the stack appropriately. And that's hard to remove all that cost. So that's the sort of fixed cost. So when you're just doing a simple JNI, like get PID is a classic example. Panama may not be terribly any faster in just for one call than JNI. And in fact, it can be. There's a notion of trivial. I can't remember what it's called. A trivial method where we can, if the native method that you're calling is doesn't take a long time, subjectively, doesn't do much, like get PID. You can reduce the transitions because you can say I'm going to block GC here. And I don't care about GC because it's so small, it's not going to affect the GC. And JNI has a private mechanism to do that some people use.
Okay.
You can expose that publicly through Panama now, so you can use that in a public fashion. So you can get faster that way using publicly endorsed APIs. The second one where Panama can greatly improve matters is upcalls. So if you have a callback coming back to Java, Panama optimizes that. I can't remember the numbers. It's like 3 or 4x compared to doing the equivalent in JNI. So if you've got a lot of upcalls, like you're doing async functions and you're getting callbacks, that's hugely beneficial.
So it's used in profilers a lot, right?
It could be, yeah. I'm trying to think of it. The example the InfiniLeap UCX example is a good one where they benefited a lot from upcalls. It makes a big difference. GPU cases could be as well, where you're doing async. You want to get notified when your kernels have been called or some profiling on them. I'm guessing you'll do an async call and you get a future that you have to get callbacks on or you have to poll. The third area is because, and I don't know if there's a lot of optimizations been done yet on this or where potential is, because the native invocations through Panama are much more visible to the compiler. You may be able to coalesce or do some sort of coarsening of transitioning because it can see, oh, there's a call here, a call here, a call here. When you're inlining, it may be able to do further optimizations, more global optimizations compared to what you can do with JNI in there. So there's potential more optimization possibilities in the future, maybe.
So what Panama then is, that you can just work more or less with pure Java, I would say, right? So you can if you J-extract, it means what you get is the C representation, almost like a stub of the C function, and you can wrap it, make it nicer. The job is actually to make it nicer. And what you did, you created a nice Java metrics API, which uses behind the scenes from Java perspective, ugly low-level C API generated by C extract.
Exactly. Right? Yes. Yep. I'd say that's it. And another thing is because you're always dealing with native memory with Panama. You're not dealing with Java objects. There's potentially another performance boost too, that you're not having to deal with that translation aspect. And that can sometimes have a cost as well. So memory segments effectively represent a pointer to something, and your layout describes what it's pointing to. And you're often dealing with natively, and you can then handle the memory in a way. You can choose to handle the memory differently. For example, you can choose to handle memory in a sort of native arena that you can control the allocation and where all the deallocation happens. So there's potentially other performance boosts in the way that you handle the memory as well, that you don't get out of the box with JNI in the same way. And that's interesting too, because often some of the performance is often around how you allocate and reallocate memory or reuse it in some cases. And that can be a big boost as well.
So the Project Panama comprises, I think, 3 parts, right? This foreign memory access. Foreign function, memory management, and the J-extract, right?
Yes, those would be the 3 things. Yes.
So, but I think mess up the memory one. The formal name of the foreign memory access, is it?
Oh, it's memory segments would be.
Memories, okay.
Yeah, so there's memory segments, then there's a linker, the foreign function interface effectively, and then the J-extract tool. And the foreign function interface will use the memory. You can think of it layered. So you got the memory segments, you got the linker, and on the side you got J-extract, which is going to generate the artifacts that you can use.
But the J-extract would create the structs from C, so the memory layout plus the functions.
Yes, the method handles or the methods which hide the underlying very low level.
Okay, very good.
Yes.
So exactly. So then the J-extract is between both. It's between the memory API and the foreign function.
Use both of those.
It's both. Okay.
That's right.
So I think I would say the foreign function API is more or less straightforward, right? I mean, you call the C API and basically done. And with the arenas, it's more about memory, right? Yes. So with the arenas, it's something like my understanding is a data structure, and whatever happens in the arena happens, and everything is collected or freed after the arena is closed, right? So this is my understanding.
That's right. Yes, it's very classic arena. In the old sense, I think these concepts have been around since the 70s. I think in terms of computer science, if I recall. So it's a way to more control the allocation and deallocation of native memory. And if you remember, we had direct byte buffers, but you had no control over the deallocation. It was when the GC decided that it wanted to do it, which is interesting when you're using technologies like ZGC, which tries not to do a GC at all. And so you just end up accumulating. It looks like a memory leak in some respects.
Back to byte buffers and memory map buffers, I think was the name, right? Mm-hmm. So the idea was back then, I remember, is that you could have a byte buffer, write to it, and it was maintained by the operating system. So behind the scenes, the byte buffer was asynchronously read and filled by the operating system, right?
And it was very fast. A memory map, doing a mem map to a file?
Yeah.
Yes. You can have a byte buffer that maps to a file, and natively it calls the mem map on Linux or whatever the native method calls.
And this was called off-heap storage.
No, off-heap would be... yes, it's confusing because there's different terms for this. There's a notion of heap buffers, which are managed by the VM and GC. Mm-hmm. There's off-heap buffers, and they're also called direct buffers, mm-hmm. which is memory that's not managed by the VM, and you can call it native memory. And that memory could be paged in from anywhere. So it could be memory in RAM, or it could be memory mapped to disk, or it could be network memory. It's abstract in that sense. And so how do you get that memory? If you want to get the memory from a file, you map a file ID mm-hmm. into memory. Mm-hmm. And when you access the pages, they get swapped in from the disk.
But what was the name of the class? Wasn't it memory map buffer, byte buffer?
Something like that, or it wasn't as an explicit class. It was a method to get a direct byte buffer that's associated with a file.
Okay, exactly. And why I try to refer to it is because how it was used. All the caches and databases was an enterprise feature because what they did, they pre-allocated. The problem is, I think you had to know upfront how big it is, so they pre-allocated the gigs. You couldn't resize it, I think, back then, and you allocated a blob of bytes, and they managed the blob for you. And this is where the data was stored. So this was old tag. It's called off-heap storage. And allocate direct, you said, right? It was the method name, and you could have it on.
I can't remember. I'd have to look it up.
Yeah, this is what I remember. Is this was memory map buffer had was the classic one, and good. But we could do this with Panama. This was my thing. This was the old way of doing this. And the new way with Panama, we could use the memory API of Panama to do similar things like with the, how we called it correctly? I forgot it, byte buffer with direct allocation to memory or file, right?
I can't remember. I was trying to look up in the APIs quickly what the API points are, but I can't remember it off the top of my head. There's a method somewhere, I think it might be on file channel or something like that, which allows you to map a file in and you get a memory segment back from it, and that is a pointer to memory that the operating system has mapped from a file. So if you were to do some sort of, on Linux, if you use the Linux tools, you could see that memory being mapped in through some, I can't remember, proc or something like that. You might see it. That's a great way to slurp in lots and lots of data. Very efficiently. In fact, we do that in the files.lines method, which turns a stream of lines. It actually
is it allocate direct?
Allocate direct will give you a native piece of memory allocated, which is not managed by the GC, except it will be managed in terms of freeing the memory. Once the byte buffer is lost, that's the only type of management. Otherwise, the VM has no idea of what size that memory is or what its pointer is or anything, and it's fixed as well. It won't move.
Exactly. So you have to provide the capacity in integer, and
that's right. And of course, it's restricted in terms of size to integer. You can't create a very big segment natively, unlike Panama with segments. So you can do everything you can do with byte buffers with segments and more effectively. You think of segment as a better form of byte buffer
Okay.
in terms of capabilities. Perhaps a little different in how you use it, but it's immutable. It has no state associated with it. With byte buffer, you have a state of an index it keeps track into as well. So that makes it harder to optimize as well. So I think it's a much cleaner model for today's way of interoperating with memory and native. In prior times, way Neo and buffers were designed was influenced by the current thinking at the time, and so it wasn't wrong at the time, and it's not necessarily wrong now. It's just not as suited for the purposes of how we want to do things. That's a reasonable way of describing it.
And are there any advantages of using the old byte buffer over Panama?
Yeah, interop, because lots of things that consume byte buffer APIs. But I would say I would try and reach for memory segments if you can, rather than byte buffer. You don't need to interop. Plus, also you can also get a byte buffer from a segment if you need to interop as well. So it's not a terribly costly operation. It's just an implementation of byte buffer that knows it's backed by a segment.
I remember also the attempts you could use the memory map buffers to pass data to GPUs.
You can, I wouldn't say memory mapped, I'd say direct or native memory.
Okay, so this is my memory. What I think memory map is this direct memory access, but the name seems to be different. So this is what...
Absolutely. So it's native memory, direct memory, off-heap memory. They kind of all mean the same thing. When you talk about mapped memory, to me, I'm thinking, you're mapping a file into memory.
Okay.
So yes, and in fact, the interface between host and GPU should only be native. We shouldn't be passing any Java objects across because it's too complex. In fact, the interface should be very similar to how the Panama linker works with regards to native, and we should do the same for GPUs. So a native pointer of floats or something like that, or wrapping a tensor around something that points to floats with shape information. It should all very clean model, and I think is mostly how people would expect it to work. I don't think people would expect passing a hash map over from the Java side to the GPU side. And in fact, the complexities around that are enormous to try and get that to work, because you'd need notion of GC on the GPU side and code gen from hotspot on the GPU side, which is complex. I think we can layer these things out and keep hotspot focused on the CPU, at least for now, and layer on top the GPU as a library with Panama and Babylon.
So we covered, I think, pretty well the Panama project, right? Anything else? Any feature which we didn't mention, which is maybe important?
I think there's there's ongoing ways to think about how to use memory segments and how to map memory segments to high levels of Java language constructs, like extracting out from a segment and its layout, extracting out data as a record. For example, if your layout represents a table of rows, you may be able to extract out a record per row easily using some notion of mapping. So we're looking at facilities to make it easier to interoperate with memory at a high level. That includes like mapping to records, like copying to and from, or perhaps mapping high-level interfaces as views over segments derived from the layouts as well. So I think that's a common one we might want to use for GPUs. So we're thinking, once we've got the basics in and the foundations, there's more we can do to make it easier for developers to use these things.
So you would like to have a nicer Java code, right? So this is...
Of course, always.
Always
push it, yes.
But when you said interfaces over memory segments, what this implies... records I would understand, but interfaces more like operations, right?
Well, they would be more proxies or views over the data. So you could imagine an interface that represents a structure with gets and sets.
Okay. Okay, I get it. Okay. Yeah, but then we are also callbacks, right? If the memory changes, maybe it should be a listener on the Java side.
Perhaps, depending on what you want to do. I mean, it's very much dependent on what you want to do. But rather than trying to peek and poke at the offsets yourself and work out those calculations or create var handles that do that, there's a high-level abstraction to view the memory, which makes it easier to sort of read and write to it. Now, the question of whether there's multiple things reading or writing to these things, I'd say is a separate problem and a hard one in general to reason about.
So, on which task are you working currently? Just more
Babylon.
Babylon. Yes. And what is your next goal?
My next goal on that is to publish another document, publish the auto-diff. So there's going to be one on how to emulate some aspect of C#'s link.
Okay, that's interesting.
Yes, I hope it is. Again, I hope it inspires people. That's what they're really there for, and to see people have ideas and they can use these to take these ideas. And then the next one, after I have another article to write and some code to push as an example around supporting the notion of writing Triton programs in Java. Triton is a sort of platform by OpenAI that allows you to write Python code, which is a constrained programming model, and then compile it down to efficient GPU code. And I wanted to do the equivalent and show, hey, we can do this in Java, at least the bits of writing the bits in Java, and then setting it up so that you could compile it to GPU. I'm not going to do that bit, but its setup could be very similar after that. So I wanted to prove we could do that as an example, again, to inspire people. And that one comes with some more substantial code.
So, but Triton is similar to Babylon then? This is the OpenAI way?
Triton is not. It's very... Triton would be a use case.
Yeah.
In effect, what Triton is a way that OpenAI have sort of a platform for developers to quickly generate efficient CUDA code without the expertise requiring the expertise of a CUDA developer, which are probably more expensive to hire, I'd say as well, in that sense. But we can do the same in Java. Pretty sure of it, and so I have a proof of concept.
Very good. That. So I'm looking forward to this one. So C# link is also very pragmatic because the C# link was, a huge discussion before Java had streams. I think they were first with the
link is very stream based as well. But in the context of code reflection, I'm interested in the aspect where C# can sort of introspect on the query it's built up and then translate it to SQL. And it's that kind of aspect I'm interested in, because that's where a code reflection could come in and do an equivalent type of thing. So we're not binding this to streams like Link is doing, but someone could design an API, a Link-like API that does the equivalent of expressing SQL statements or something like that. So again, to inspire people and see if they want to take it further.
Very good. By the way, I see your name hundreds of times a day because currently I'm working on JAX-RS. And every control space is Paul Sandoz because I have a Java doc. This is a really nice. I will never forget, an appointment with you because I see you all the time.
Really, that code is still live. It's still going.
Yeah, and what I meant is not memory map, is mapped byte buffer. This is the class name I meant. This is this is able to map the regions, and for unknown reasons I always say memory map, mapped by buffer. This is just the abstract class, extends byte buffer, and it comes then with compact, duplicate, flip, the basic things load, and it is described similar that it can be mapped to something, and I think one representation is then the all implemented interface is comparable. But this is what I meant, at least, is map by buffer. Back then, it was JDK 1.4, so a long time ago, but it was revolutionary back then.
This is the one that represents not like memory and RAM, but potentially memory on disk.
Yeah.
So,
But this is what I remember, because back then it's okay, we can just write to memory and it's just managed by the operating system and write somewhere to disk. And this was really interesting in enterprise project because we can have, like very fast storage, right?
Yes, you can. Yes, and it's persistent as long as you manage the transactional aspect yourself on top,
sure.
Which is a challenge. This is kind of like a bit like persistent memory, isn't it? It's there's another interesting technological area that's still struggling to break through, I think.
Yeah, there's the MicroStream project as well, which tried to doing this actually. It's called, also Eclipse Store is called. What they're doing, they are persisting all the Java objects very fast using a custom serialization to memory, and they're also using byte buffers. It's open source.
Yeah.
Okay, Paul, thank you. I have to reinvite you back to talk about vectors, and whenever you're involved, the entire Babylon ecosystem, we should cover more and promote it a bit, because I think this is, I mean, not future of Java, but this is, I think, the ugliest part of Java right now is JNI, and if we fix it, we get a better integration with Onyx, for instance, and if we get better integration with Onyx, this is the same what Python developers have. They have a nice integration with Onyx.
Yeah, I agree, and I really appreciate you having these discussions, because I think it's good to share these ideas and see if people are interested and want to play and prototype these ideas and see how far we can take them.
So then I would say thank you, and we talk the next time about whatever is interesting. The Java native edge, right? So this is living on the edge should be name of the project, I think.
Yeah.
Thank you a lot.
Okay, thanks so much.